Okay, so I'm going to be doing a brief lecture on how to use ray diagrams to understand images that go through lenses. First, we're going to talk about converging lenses. So for converging lenses, we typically draw them like this, with a line down the center, which we call the principal ray, or the principal axis. And when you have a converging lens, you're going to have some focal point, which we call F, and then it's going to be mirrored on that distance on the other side. So if you have a ray coming in, then the converging lens bends the ray and sends it straight through the focal point. So what do we use these rays for? Is we use them to determine four things. First, we want to determine the location of the image. Second, we want to determine whether it's virtual or real, which in a way is connected to the location. Third, we want to determine the size of the image. And then lastly, we want to find the orientation. So in order to do this, first we need to define two lines. So if we have our principal axis coming across, and then our lens, we have focal point here and here. We draw our image as an arrow, and the first line that we draw goes from the top of the arrow and then perpendicular to, or I apologize, parallel to the principal axis until it gets to the center of the lens, and then it bends in a straight line down through the focal point. And then the second line that we draw starts at the top of the image and will go through the center of the lens. And then if you extend these out, the place where these cross, this is the image point. So now if we want to find out what can we do for these to or how can we use these diagrams to understand these four properties here. So to do this, we go to the image point, and we draw a line from the principal axis down to the image point. And then this location and this line tell us all the information that we need to determine these four things. So along this axis, wherever this, we'll call this point A. Point A is going to be the location of the image. So when you draw back up wherever it lies on this axis, that's where you would find the image if you actually did this experiment. Next, whether it's virtual or real depends on where it lies in respect to the lens. So if it is on the opposite side of the original object, then we call it a real image. And if it ends up on this side of the lens, we call it a virtual image. So in this case, we have our image point at A, and it's a real image because it's on the opposite side to our original object. The size of the image relates the size of this arrow, or this object, to the size of our image arrow. So in this case, we can see that our image arrow is much longer than our object. So therefore, we're going to have a larger image in this case. And then lastly, the orientation is determined by which way this arrow points in comparison to this arrow. So in this case, we have this arrow pointing up and this arrow pointing down. So we have that the image you'll see is flipped. So another example of this that brings in how we would get a virtual image. Now let's put our object in front of the focal point. So we'll put it here. And then we do the same process. We draw a parallel line straight to the center and then bend it down towards the focal point. And our second line, we draw straight through the center of the lens. So we can see that on the right side, these arrows are never going to touch. So if we want to find the point where they cross, we need to trace these backwards to see where they would cross. So in this case, we see that when we project these lines backwards, that they cross up here, and we draw an arrow to that point. So again, we can look at our 4 different criteria that we want to determine, and we can see the location of the image is at point B. We'll call that B. And because it's on the same side as the original object, we call that a virtual image. Again, this arrow is longer than the object image, so it's a larger image. And this time the orientation, or the arrows point in the same direction. Therefore, we have that you will see the image in an upright state. So then the second type of image or lens that we'll talk about is a diverging lens. So all of the ideas that we have still hold, except now we draw a diverging lens this way, and they still have some focal point. So now if you draw an object, and you go over to the center, instead of bending down towards the focal point, it will bend away from the focal point. And then again, we draw a line from here going through the center. So the second line we draw is the same, but the first one bends in the opposite orientation. So now we take this line and we project it backwards. So now this point is where we see the image. So this will be C, our image point. So the location is at C, and again, we are on the same side of the lens as the original object, so our image is virtual. In this case, however, we have our arrow is clearly smaller than our object. Therefore, the image we see is going to be smaller, and it's still pointed in the upright direction, so the orientation will be upright. So last thing I just want to discuss really quickly that I think could be confusing is the axes we have here. In this direction is X, and in this direction is object height. So if you have that the image is here, this is going to be still on the x-axis. If you were to perform this in an experiment, you would have your light coming across and you would see it on the x-axis. This isn't an xy plane. So you wouldn't see an image potentially up here. You would always project that point down onto the axis, and that's where you would actually see the image. So what this gives you in the up and down direction is always the object height. It is never going to be the location in a 2D plane. All right, Mateo.